Okay. Uh, so we've had I believe 3 or 4 lectures about stoichiometry and related to recipes, and it looks like a lot of you are getting it pretty well. I received a lot of people's homeworks already. that uh, quiz one is due today, and I gave you the due dates for the other one. This will be there will be a quiz about this PowerPoint that'll come out uh, probably later today or tomorrow. So let's say this. So this is called limiting. This is called limiting stoichiometry. Suppose you have the following recipe table, and let's say you start with 6 cups of flour. And for each recipe, there's 3 cups. And if you have 6 cups, you can do the three. You can do 3 cups per recipe 2 times. So what you do is you divide the 6 up into groups of 3 cups per recipe, and you can do the recipe twice. Okay, that's pretty simple. So we worked on that, and in the pre. All right, now let's make it a little more interesting, I guess. So let's say we have 6 cups of flour, 4 cups of sugar, 1 cup of milk, and 4 cups of eggs. And I want to know how many times I can do the recipe. So take a look. So we have 3 cups of flour per recipe, 2 cups sugar, 1 cup milk, 2 cups eggs will make our one cupcake. So how many times can we do the recipe? Okay, well, hopefully you'll see is that you can only do it one time, and that's because of the milk. Because it's the flour, you can do it twice. You can see that with the sugar, you can do it twice. With eggs, you can do it twice. But with the milk, you can only do it once. So overall, you're going to run out of the milk before you run out of the other guys. So you can only take one recipe or one cupcake. So everything else except so the milk is what we call limiting, and it determines how much cake you're going to make or how many recipes. And the other ones, the flour, the sugar, and the eggs, are excess. They're in excess, and you won't be using them all up. Well, let's formalize this a little bit and put it in our table so to see how I'll see that it makes sense. So you put the 6, the 4, the 1, and the 2 in their appropriate spots. And then you figure out how many recipes each one can make. So the 6 cups flour can be divided up into groups of 3 for 2 recipes. The 4 cups can be grouped up into 2s for 2 recipes. The 1 cup milk can only be grouped up into 1 recipe. And this should be a 4 right here. I'll fix that. It can be put up into 2 recipes. So you can only do this one time. So that means you're only going to make 1 recipe, which you make only 1 cake. So that's what we're going to be looking at here, is what happens if you're given more than one of the ingredients. How many recipes can you do? And then how much of your product can you make? And so what we're going to do is apply that to chemistry. Okay, so again, we're going to apply this to chemistry recipes or chemical equations. For example, let's use what we've been using before, pentane plus oxygen, combustion of pentane. Let's say we start out with 5 moles of pentane and 16 moles of oxygen. All right, so every time you do a pentane, the one recipe, you need 1 pentane. So with 5 moles, you can do it 5 times. With the oxygen, you need 8 moles per recipe, and you have 16. So you can only do the recipe twice. So the limiting is the oxygen, because you're going to run out of it because you can only do 2 recipes. Pentane, you can do 5. So you only do 2 recipes. So that you can bring that over here. So you can make 2 recipes of the carbon dioxide. So that's going to be 5 2 times for 10 moles. And 2 recipes of water. So each recipe is 6, so you do that 2 times, and you get 12. So again, what it is here is the limiting. So what you have to do is take your moles, figure out the number of recipes for each one. The smaller one is going to determine how many recipes you do, because you're going to run out of that amount of recipes. And that's going to determine how much of the product you're going to make. Okay, when will you need to be able to do this? Okay, this type of reaction you'll do when you have more than one reactant. In the previous reactions, you had only one reactant. Okay, this one you have two. You have the pentane and oxygen. In that case, what you have to do is you have to figure out which one you're going to run out of first, the limiting. So the key is to find the amount of moles of each reactant, then how many recipes each will produce. The lower amount determines the amount of recipes and how much product will be made. Now, just like in the previous examples, if you're giving grams, you're going to have to figure out how many moles first and then figure out the recipes. So we're going to do a couple of examples here. And what you're going to do is, first of all, find out what your limiting reactant is, the number of recipes you can get from that, and then how many moles and grams of the product you'll be getting. Now remember, this is only if you need one reactant. I mean, if you have more than one reactant, and it has nothing to do with product. So if I gave you a certain amount of product to figure out, it doesn't work. It only relates to be given to the reactant, to the left side of the reaction. Okay, so example 1. Let's say you have 10 moles of pentane, right here, and you have 24 moles of oxygen. So the first thing you have to do is figure out how many recipes each can do. So you divide the moles by 1 mole per recipe, so you can do 10 recipes with the pentane. And with the oxygen, you can do 8 per recipe. So you can take 24 and divide it up into groups of 8, and you can do it 3 times. So with pentane, you can do it 10. With oxygen, you can do it 3. So you're going to run out of the oxygen way before you run out of the pentane. So the oxygen is your limiting, and you can only do it 3 times. So you bring the 3 over here, because that's the amount of recipes you can make. And then I ask you how much water will be formed. So to figure out how many moles, so each recipe you have 6 moles. So you do 6 moles 3 times, and you get 18 moles. And then to figure out the grams, each mole was 18, and you have 18 moles, and that turns out to be 324 grams. Okay, so again, the key thing is to figure out the recipes, compare them. Lower amount is your limiting, and that'll affect how many recipes you do. Okay, with this example, we're going to start out with grams of pentane and moles of oxygen. So now what you have to do is first figure out how many moles of pentane that is. Then once you do that, you can change them both into moles, and the lower amount will be your limiting. So you need to use molar mass of pentane, which is 72. So if you have 144 grams of pentane, you can divide that up into groups of 72 grams per mole, and you can get 2 moles. And from those 2 moles, every recipe, you need 1. So you can do the recipe twice with 2 moles. Okay. Over here, you're given, for the oxygen, you're given 40 moles. And you take that 40 moles and divide it up into groups of 8. So you can do 5 recipes. Each recipe is 8. You have 40, so you can do 8 5 times. Okay, so now what you do is compare the amounts of recipes you can do for each reactant. For the pentane, you can do it twice. For oxygen, do it 5. So you'll see that you'll run out of the pentane before you do the oxygen. So that's how many recipes you can do. So you bring the 2 over here to the product side. So you can do the recipe twice. We're looking for carbon dioxide. So we're going to do 2 recipes. Every recipe you have 5 moles, so you can do 5 moles 2 times, and this should be a 10. And then 44 10 times would be 444 grams. Okay. All right. Finally, the third example is what we're gonna do is have grams of both. So 720 grams, 480 grams of oxygen, and this time we're gonna figure out the limiting reactant, number of recipes, the moles and grams of both carbon dioxide and water. Okay, so we put 720 and 480 in their proper spots. Figure out how many moles and recipes. So if you have 720 grams, divide that up into groups of 72, so you can take 720 and break it up into groups of 72 and you'll get 10 moles. Every recipe, you need 1 mole, so obviously you can do it 10 times. That's for the pentane. All right, now we have to go to the oxygen and see how many recipes you can do with that. So you have 480 grams. Each mole is 32, so you divide that up into 4,800 up into groups of 32, and you'll end up with 150 groups, or 150 moles of oxygen. Every time you do a recipe, use 8, so 150 moles, you can break that into groups of 8, 18.7 times. So what we do now is compare the amount of times I can do it with the pentane and the amount of times I can do it with the oxygen. Right, 10 times for the pentane, 18.75 times for the oxygen. I'm going to run out of the pentane first, so that's the limiting, and I can do it 10 times. So I bring the 10 over here, because that's how many times I can do the reaction. So for the carbon dioxide, every time you do the reaction, you have 5 moles, and do that 10 times, you end up with 50 moles. Each gram weighs 44. You have 50 of them. So it's going to be 44 50 times, or 2,220 grams of carbon dioxide. Okay, in terms of water, we decided we could do the reaction 10 times. Every time you do it, you make 6 moles. So every time you do it, make 6 moles. You're going to do it 10 times. So you're going to make 60 moles. Each mole weighs 18 moles, 18 grams. So 18 grams per mole. You have 60 of them, so you're going to do 1860 times for 1,080 grams. Okay, so that's your answer. Okay, one thing to notice. When we were doing these tables before, we saw that the sum of the mass of the reactants, this guy plus this guy, should equal this guy plus this guy. So let's look to see if that works here. So the sum of the reactants here is 720 plus 4,800, and that's 5,520 grams. So there's a total of 5,520 grams on the reactant side. Now how many grams are on the product side? Well, there's 2,200 from the carbon dioxide and 1,080 from the water. And when you add those up, you get 3,280. And if you notice, they don't equal, and there should be a cross right there. Why is that? Well, that's because you have the oxygen is in excess, and so a lot of this oxygen here doesn't get used. In fact, you could figure it out. It's on the order of 2,200 or something. Just the difference between these two is how much oxygen left over. You won't have to figure it out. But the reason why these don't add up is because you have excess oxygen. Okay, so you can't use that as a check. All right, that's it. But I'll send you a worksheet to deal with these guys, and then we'll figure out when we're going to have the test. All right.